guys. Good morning. Good morning, everyone. I'm audible?
Yes, you are.
Yes, you are.
Okay. 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 So the plan for today's classes will be starting with Pandas, guys. Okay. So we'll be starting with Pandas, and we'll see how many topics I'll be able to cover in today's class. Okay. So there's no rush, but again, we'll try to uh, complete. But we'll try to work on the topics, not just as a theoretical part. We'll try to work on the topics as well. Okay. So that is the plan. So in that case, right? So of course, you need to have the data sets which I'm going to work upon. Okay. So there are some sample data sets which I have actually shared for all of you guys. What I want you guys to do is basically download this particular data sets in your local machines as well. Okay. So you see in my folder where I have my Jupyter notebooks, I have this particular datasets folder, right? So I have shared this particular dataset folder in the drive link. So please download it, guys. Okay. So if somebody can share the screen, I'll guide one person and others can follow the same. Anyone who would like to share the screen?
Yeah, I can share mine.
Sure, Ashwin.
Yeah.
Okay, so I'm going to show you where this particular datasets folder are. Just download it and we'll be moving it to the place where we'll be working it. That's it. Okay.
Yeah, 1 second.
Yeah, sure, Ashwin.
Yeah. Can we start?
Yep. So now open the drive link where you have this class notebooks uploaded, Ashwin.
Yeah. This one?
Yep, open it. Python by Israr. Yeah. Okay. Now you have this data sets now. So click on the three dots and download it.
Okay.
Now go back. Download the complete folder. Yes. Download the complete folder. Okay. Everybody do the same thing, guys. Okay. So Ashwin, can you share the link in the chat box? This link.
Yeah. Yeah, done.
Thanks a lot. Okay. So in this link, just download the complete folder, guys. Okay. So as there are many files, right? So it will get downloaded as a form of a zip folder over there. Okay. So now go to your downloads folder in your file explorer.
Yeah. 1 second.
Oh, I think that is not visible for us.
No. There are two screens.
Oh, okay. Okay, so go to downloads folder, right? So
Yeah.
everybody should be able to see the zip file. Okay, so now what you have to do is unzip this particular file, Ashwin.
Yeah.
Right. Yeah. Okay, so once unzipped, right? So click on the data set. You should be able to see all these particular files over there, right? So these are the data. This is the data which we'll be working on. Okay, so everybody download this, unzip it. Okay, once done, right? Now move this folder to the place where you usually create your Jupyter notebooks, Ashwin.
The whole thing?
Yeah, just move the complete folder. Copy it and move it to the place where you usually create your Jupyter notebooks, no? Over there.
Just checking. Yeah, these are folders where I create my
Okay.
you want
Jupyter
to put it
notebooks.
here or today's folder?
If required, you create today's folder.
Okay.
Yeah, and paste it. That's it. Okay, so everybody do this, guys, right? So just nothing but download, unzip it. Once unzipped, move the dataset folder to the place where you are working on. Okay, now in your Jupyter notebook, go to that folder, today's folder.
Yeah, today's 2015 November. No? Yeah.
Okay, now create a Jupyter notebook over here. Exactly. Done. Okay, so everybody do this and confirm. Once done, then I'll proceed, guys. Okay, so let me share my screen back again now.
Yeah, sir, I need some help. Can I share my screen?
Yes, Kushal.
Yeah, I'll share my screen.
Yeah, quickly. Everybody confirm once done. Ashwin is done. Others, guys.
Yeah, where I have to go now? Let me.
Python Israr. Python by Israr. Yes, that one. And data
Okay.
sets. See the three dots. Right click and then three dots.
Yeah,
Download.
download.
Yes. Download. This is Windows 11, right? Okay.
Yeah,
Give it a minute. It will get downloaded. It's downloading. Downloaded. Okay. Go to your downloads folder.
data set.
Go to your downloads folder.
Sir, could you please give us the link?
Data
I
set.
joined late today. Just joined.
Okay. I'm sharing the link again. No.
Okay. Thank you.
Okay. Kushal, right?
Data set.
Kushal. No,
Yeah,
go
yeah.
to downloads folder. Downloads folder, you go.
Where is that?
Left hand side.
This one.
Yes, that one. Yes. Now right click on this one
Yeah.
and unzip this one. So extract all in your case.
Yeah, yeah. That's all.
Uh, Click on extract. Then right now double click
Data
on
set.
this data sets. Okay. Now go back. Go back one folder. Hmm. Control X this. Control copy this from here.
Copy. Yeah.
Copy it and move it to the place where do you usually create your Jupyter notebooks? Which folder?
Yeah.
In your local machine, right?
Yeah,
You
here.
create it in scroll up. Okay. Then go to your file explorer. Go to your file
File this.
explorer. No. File explorer. One second. I'll give me the control.
Yeah.
Done. Thank you. This one. Okay. So your C drive
Yeah, I can see. Yeah, yeah. Inside.
users and then Kushal. Okay, so this is where you usually create your Jupyter notebooks. Okay, so that's why I'm pasting it over here.
Yeah, yeah.
Okay, so done. I have pasted it over here. Okay, now if you go to your uh, Jupyter notebook and refresh this one, you should be able to see the data sets. Notice over here it is
Okay.
present. Okay,
Okay.
so
Yeah.
one second. Yeah, so you can work on it. Okay.
Okay. Thank you.
Okay. Now let me share my screen back. Everybody done?
Sir, we don't install the Jupyter notebook. It's giving some error. So I'm using the Colab. So could you please tell me how to extract there?
No. Can you repeat again?
Yeah, Jupyter notebook is not there in my PC due to some issue. Okay, I'm
Okay.
unable to install it. So I'm using the online compiler. So could you please tell me how to extract that?
Uh, Share the screen quickly, Rajkanya.
Yeah, just a second.
Umang is done, Shreya is done. What about others? Anita, Anuj, Arup. Keshav done, Anita done. Murli is also done. Arup is also completed. Others just confirm once, guys, in the chat. Zubair is also done. Shobana, Saikat, okay. Praveen is also completed. Somita, Somit,
Yes, sir,
Siddharth.
sharing my screen right now.
Mm-hmm. Quickly, Rajkanya.
Okay, entire screen.
Everybody is also completed.
But I'm unable to share that.
You're using Windows or Mac?
No, Windows only.
Okay. Click on share, entire screen. And then again,
Yeah,
one more of share.
Sure, I just joined. Are we installing something? Can you just give me the link? I will.
No, we are just downloading the datasets folder which I have uploaded, Bhavna.
Okay.
I have shared the link.
Share option is not editable. It's grid out.
Oh, okay. Then are you using your office laptop?
No, personal laptop only.
Okay, so then do one thing, Rajkanya, no?
Okay. I'm using Colab, so could you please tell me the
Okay,
steps?
I'll show you how do you do it in Collab, okay?
Okay, no problem, sir. Thank you.
Okay, done. Just a minute. So if you're using Google Colab, right?
Mm-hmm.
1 second, let me share my complete screen.
So
Hope
after
everybody.
downloading what? Yeah, sure.
So what you have to do is basically after downloading this dataset folder, unzip it because there are many things, right? So it will be a zip folder. Unzip it, then move it to the place where you usually work on. So what will happen is basically you should be able to see your dataset folder. See, I have my Jupyter notebook over here. I have my dataset folder over here. If you double click on this one, you should be able to see all the files.
Oh, okay, it should be in that folder. Okay.
Yes. Okay. Now,
Hi, sir.
it's
Hello.
what you have to do is see if you are using Google Colab. Okay. So let me also create a new notebook. Hope you have downloaded, right? Okay. So if you have downloaded it, so see on the left hand side, you should be able to see one option for files. Okay.
Yes.
So two things you can do. You can actually mount the drive as well, or else over here files. You can click on this upload, and all the files what and all are present, right? So those all files you can actually go ahead and upload it over here.
Okay, extracted folder, right?
Exactly.
Okay, sir. I'm
Okay.
doing.
Okay, done. So let me proceed, guys.
Hello, sir. Hello.
Yes.
Sir, hi. I just joined. My laptop had crashed actually. Did I miss something?
We are going to start right now. Until
Okay.
then, please download this dataset folder and move it to the place where we are working on. That's it.
Okay, sir. Could you please share that data set, sir, in the chat?
Yes, I have shared it. I think.
Okay.
Okay.
Thank you, sir.
Okay. Now let me proceed, guys. Right. So let me proceed. Okay. So let us start our today's topic. For VS Code, it is same. Yes, it is same as Jupyter Notebook. Okay. Let us go ahead and let us start our today's topic, guys. Okay. Now, if you are still downloading it, if you are still yet to move it, awesome, no worries, because it will still take me time to reach to that particular point. Okay, so first we'll start with the theoretical part, then we'll go ahead and we'll start working on the data sets, right? Okay, now, yes, we have covered something called as NumPy in our last classes. Okay, so we have covered NumPy, and today we are going to start with something called as Pandas. Okay. So Panda, right? So now one question is, see, why do we use NumPy for our data manipulation? What is the use? We can even do it in our core Python as well, right? So why do we use NumPy? Any idea? Do you guys remember this point?
Because work only on numbers.
It's faster.
We can work. Yeah, it is actually faster. Why? Because that particular library is written in which language? That is in C language, right? So comparatively faster, right? So now, okay, so if that is faster, then why can't we do everything in NumPy, right? So that is a problem, right? So now why can't we do everything in NumPy? Why do we require pandas over here? Okay, but there is a problem in NumPy. Okay, so for an example, one column integer. Okay, there was one point, right? So NumPy, all the arrays should be what? Heterogeneous or homogeneous?
Homogeneous.
Homogeneous, right? So over here, let's say over here there are multiple columns and multiple rows, right, inside the data. Okay, if one value is string, the whole array tends to become a string, correct? So if one value is integer, the whole array has to be an integer. So we do not have an option that, okay, one column, let's say it is integer, second column it is string, third column it is bool, fourth column that is float, right? So this type of option is not available in case of NumPy. So that is why for data manipulation we do not use NumPy. Only for our mathematical operation itself we'll use NumPy. Okay, now, so yes, that is one point. Okay, so that is the first point over here is, of course, it is heterogeneous. Okay, awesome. Right, so now coming to the second point. Second point is not just that, comparatively to our NumPy, our data representation is way better, is better than your NumPy. Okay, let me show you how exactly does the data actually looks like. Okay, now when we start Pandas, now before you actually start working on the functions, what and all are there, before you start working on the programs over there, right? So you need to understand one simple concept, that is in Pandas, right? So we have two data structures. Okay, so we have two simple data structures. Okay, so what are the two data structures which we have is, one is referred as something called as series, and the other one is referred as something called as data frame. Okay, now you can ask me, hey, what exactly is series? Series is nothing but our one dimension data. Okay, what about data frame then? It is nothing but our two dimension data. Okay, so in simple words, it is something like this. You'll imagine an Excel sheet, right? So in an Excel sheet, you'll have multiple rows and multiple columns as well, right? So this type of data you should be able to see in an Excel sheet. Okay, if you capture one single column, it is one dimension data, correct? So remember, either one row or one column is referred as one dimension data, right? So this is what will be calling it as something called a series. Either you capture a column or a single row, right? So that is nothing but our one dimension data. Okay, but if we are talking about multiple columns, multiple rows, right? So at that type of scenario, we'll be referring it as something called as data frame in case of Pandas. Okay, so these are the two data structures which we have in case of Pandas. Okay, now before we understand about the functions, in simple words, how do we create a series? How do we create a data frame, right? So series, okay. Now, how do we actually create a series? What is the syntax? Which functions do we use? Let us try to understand this. Okay. Now, similar to our NumPy is not a built-in function, correct? You have to first import it in order to use this. Similar to that, even Pandas is also not a built-in function. You have to import it in order to use this. But again, if you are using Jupyter Notebook, this might already been installed. But let's say over here, so this is for the people who are using some other tools, right? VS Code, etc. For you guys, this particular tool will not be installed over there. How do you install any library? Do you guys remember this point? If I want to install Pandas, how do I do it?
Series PYPI.
Pandas space PYPI. Okay, so search for this particular library with PYPI. Okay, so you'll be able to get the first link, open this link, and install it. Okay, so this is for the people who are using some other tools. First install this tool. Okay, so here if you're using Jupyter Notebook, need not, because here we have it pre-installed. Okay, once installed, then you can go ahead and import this particular tool. Okay, okay, so import Pandas, right? But as we saw for NumPy, the common alias given is NP, correct? So in the same hand side, for Pandas, the common alias given over here is PD over here, guys. Okay, so it is not compulsory that you can have to only take PD. Now you can take anything. You can even take hello underscore world as well. Anything, it is possible, right? So as long as it meets the rules of our identifiers. But again, so PD is the common alias which is used everywhere, right? So Pandas as PD. Okay, first import it. Done. Now let's see how to create a series. Okay, now if I want to create a series, what is the syntax? In Pandas, we have a simple function that is series over here. Okay, now imagine one thing. Let's say over here I have a list. I have a Python list. Let's say the list contains random data. Let's say our names. I'll just take. Let's say something like this. I'll take our names, right? So let's say Anita. I'll take that is Anuj. I'll take And one more name, let me take, let's say Dinesh. Okay, so let's say this is the data, right? So some random data. Over here we have nothing but our Python list over here, right? Now the question is, from a Python list, if I want to convert it, can I directly pass it? The answer is yes, you can directly go ahead and you can create a series out of this one. Okay, notice I'm able to create it. Okay, now from a Python list as well as a Python tuple, you can easily go ahead and you'll be able to create a series data without any issues. Okay, now if you look closely, okay, now look closely on the data what you are able to see over here, right? Now if you look closely over here on the left hand side, what exactly is getting assigned? See over here, this is the data. On the left hand side, what exactly is getting assigned? By default, the index values are getting assigned, correct? So that is 0, 1, 2, 3, 4 until whatever values which we have, right? So the index values are getting assigned now. Okay, now let's say no, I don't want to create a series with default index value. Is there an option where I can actually create a series with a custom index? Let's say if I want to provide any other values other than 0, 1, 2, 3, can I create it? The answer is, if you press shift and tab now, the answer is yes, you can go ahead and you can create it. How? So index is equals to, you can go ahead and you can pass your custom index values. For example, I'll just pass a B like this over here, right? So but again, you can pass anything over here, guys. Okay, but there is a rule. The rule is basically what? The total number of values inside your data should match with the total number of custom index values which I'm providing. So for an example, in this scenario, 1, 2, 3, 4, 5. 5 values I have. But how many custom index values I'm providing? Only 3. Will this work? The answer is no. This will not work. It will directly throw you an error telling that, hey, for the length of 5 values does not match the length of the index values. Only 3 values I'm providing, right? So this is not possible. So then how can I pass? For us, the rule over here is total number of values should match with the total number of index values which you are providing. 5 means 5 index values you have to provide. Clear? Up to this point, everyone?
Yeah, clear.
Okay.
Why do we need this series? Because by default, you already have index 0, 1, 2, 3, 4.
You have default index value 0, 1, 2, 3. Let's say Python's no. Because what will happen? So this will be, if I'm capturing a row level data, no? So each value, and here the column names will be assigned. Okay, the names of the columns will be the index value. That is why you will be actually working with this type of data. I'm just giving one hint over here. Done?
No, I didn't get it. So you are saying that
Yeah,
Okay,
same
so
question I
work
have.
and then-
okay, so see, imagine one column, right? So you have some values over here. By default, it will create a series. It will be something like this, correct? Now imagine a different case. Imagine a row over here. Okay, imagine a row. So I told you either a column or a row. If you capture it, a one dimension data, right? So it is going to be nothing but our series data, correct? Now, for row level data, let's say over here you have the name of the employee, here you have age of the employee, here you have salary of the employee, 3 column names and 3 values, right? So here the values will be present like this, and the names of the columns is what will be present over here. You got my point? Instead
Yeah,
of the default index values, you'll be actually passing the names of the columns later on.
but will it be in a sequence so that we know that, okay, first is
Yeah,
important?
you have to pass the data in the sequence. See, if
Oh.
over here by chance if I do not pass it, right? So let's say in this case, in simple words, if I pass A over here, then this will get mapped to this one. That's right. So it's like you can pass like this. It does not. I'm not telling that no. You can do it. Notice it is working fine. But only the thing is you have to map it to your column names later on properly.
Mhm.
Okay. Now Python list, Python tuple, default index value, custom index value, both are possible. Okay, but what about a dictionary? Can I create a series from a dictionary data type? Okay, the answer is yeah, that is also possible. How? Let's say over here, but there is a small change. Imagine a dictionary. I'll just take, let's say over here, name of the employee is, for an example, I'll take it as, let's say, name of the employee, I'll take it as, let's say, for example, XYZ, age of the employee, something like this, and let's say over here, salary of the employee. I'll just take, let's say, something like this. Okay, now the question is, hey, can I create a series out of a dictionary? The answer is yes, this is also possible. You can directly go ahead and you can provide your data. But the change over here is, wait, let me execute it. What is the change which you are able to see in my output now?
Index.
Automatically as index.
Index
Are there
change
any
to the-
default index values getting created in case of dictionary?
No.
No, there is no default index value. Whatever keys of our dictionaries are present, that will be assigned as a form of an index value to our series data. Clear, everyone? Okay. Now you can ask me, hey, while creating itself, can I pass custom index value inside a dictionary? The answer is no, that is not possible. It will fail. Okay, so let me show you with an example. Okay, now let's say over here. Now what I'm doing is basically, instead of having the index values as keys, I'm just trying to pass my custom index values to see if it will work or not. Okay, let me just give A. Let's say over here, let me give B, and let's say, for example, now I'll just give age for now. Okay, I want to show you something now. Okay, see, if I execute it, something critical is actually happening. What is happening over here? Look at the output. NaN is something
It
but
has been
called as null value.
It is
Something has
defaulting the
happened.
dictionary.
Okay. You can tell like that as well, but again, what exactly?
There is no such case like A and B, so null value is getting assigned to the sheet.
Exactly. Now, see, while creating a series from a dictionary, you cannot pass. See, later on, you can change the index value. That is possible. But while creating, I'm talking about, while creating a series out of a dictionary, if you provide custom index value, that will not work. Why? Because what it will do is basically it will search for this particular key inside your dictionary. If it is present, like how, notice the age was present over there, correct? So if it is present, it will take that particular value for that particular key. If this particular key is not present, what it will do is it will ingest it as something called as null value inside my data. So that is what is going to happen. Okay, so while creating something like this, it will not work. So but see, this is actually helpful. Why it is helpful? Now imagine you're working on a data. Okay, so here you have, let's say, many details. Okay, so here you are receiving, let's say, Aadhaar card. Also you are receiving, and let's say, imagine in a form of a JSON file, right? So you are receiving, let's say, the PAN number as well, etc. Whatever details, something like that, right? Now, but the thing is, I don't want to create a dictionary out of all the values like this, right? How we have over here now. I don't want to create a dictionary out of all the values. I only want to create a dictionary out of some things. Let's say, for example, index is equals to, let's say over here, I only want to create a dictionary out of name, let's say salary, and then let's say over here, Aadhaar card details, something like that, right? Now, if it is present, it will give you that particular value. And let's say along with this, I also want to take, say, mobile number. Okay, mobile number. If it is not present, I want my system to put it as null value, right? So this will help you to play around with that type of data. Okay, so basically out of all of this data, I don't want to create a series out of all of those. Only some specific things, right? So let's say name, age, Aadhaar card, and mobile number. If as long as the data is present, pick up that particular data. If it is not present, I want my system to pick it up as what? Null value over there, right? So that is how you can actually play around with this one. Clear up to this point, everyone?
So indexing has to be from the key only, from the key values only.
Exactly, from the keys itself over there. In case of dictionary, but on the other hand side, in case of your Python list or a tuple, sequencing
Custom
is
indexing.
possible. Custom indexing is possible, but only rule is the number of values should match with the total number of custom index values which you are providing.
Okay. Got it.
Okay.
Thank
Now,
Could you please repeat this, sir? The custom index value, what is the difference
so
between dictionary and here? The index
here,
value should be same, no? Something.
yes. So here the rule is the number of values. See over here, let's say for example, you have 100 names over there. Whatever custom index values which you are providing, you need to compulsorily provide 100 values over here as well, or else it will not work. But on the other hand side, dictionary, no, it is not like that. See over here, 1, 2, 3, 4, 5 items were present, right? I'm only selecting 4 items. That rule does not apply over here. So here basically it is searching key level. If this particular key is present, it will pick up that particular value, XYZ it is present. Let's say the mobile number also I wanted to be in my data, but it is not present in the dictionary provided. By default, we are taking it as null. That is how dictionary works over there. Clear?
Okay, sir. Thank you, sir. Yes.
Okay. Now coming to the critical point, guys. Okay. So actually, I wanted to do this in DataFrame, but I will do it over here because it is easy for us to understand here now. I'll store this into a variable scr is equals to. Okay. Everybody do the same thing, guys.
Duplicate key is provided.
But by default, dictionary will eliminate that one, right?
Okay.
So if the duplicate key is present, by default, our Python dictionary itself will take the latest value.
Okay.
Okay. Now, just copy and paste this data in your Jupyter notebooks as well, guys. Okay. Now, in this series data, okay, so this is the series data. Now, imagine you have a data like this. That is the series data. Imagine there is one data where one column you have captured like this. And it has custom index values instead of the default index values now. Okay. Now the question is, hey, if I have a series data, can I extract the value? Basically, can I perform indexing or slicing on my data? The answer is yes, it is possible. But what is the syntax? Okay, so how do we actually do it? Okay, see, indexing and slicing. Okay, indexing and your slicing. Okay, so indexing and slicing is possible by both over here, something, but the one which we have said, right, that is our zero indexing. That is also possible, as well as if you want, you can also perform this by your custom indexing as well. Okay, your zero indexing as well as your custom indexing. Indexing and slicing can be performed by both of these syntaxes. Okay, now yes, let me try to do it in zero indexing first. Okay, so the one which we have studied, right? So let's say over here, I need to extract Anita and Anuj, right? So the index values, what will I provide? SCR of start from what? 0. This is going to be 1. Start from 1 and go until what will I provide? I need Anita and Anuj in my output.
3.
0, 1, 2, and 3.
Four.
Okay, now 3 or 4? Quickly.
3, sir. 3.
That is going to be 3. Now, why? Okay, now the question is, see, this is 0, this is 1, this is 2, this is 3, and this is similarly 4 and 5. Okay, 4 and 5. Now the question is, see, I only wanted from here to here, correct? Now, why are you passing the index value of Arunima? What is the requirement?
Because it is exclusive.
Exclusive.
Because the stat is inclusive and the value of your stop is exclusive. That is what you have actually studied in case of zero indexing, right? So the value of your stat, this is what it is inclusive, but the value of your stop is what? So basically the value of your stop is nothing but our exclusive over here. Okay, that is what we have actually studied until now. But if in case of pandas as well as even in NumPy also, which we saw, right? So in case of pandas, in series as well as data frames, okay, so same thing I'll be doing it in our data frames as well. The indexing and slicing can also be performed by custom indexing. For an example, let's say over here, start from B. Okay, so start from B and go until, let's say, for example, D. Okay, same thing what over in indexing which we have provided, right? 1, 2, 3 I have provided. Now here also same thing. See, start from B and go until D I have provided. But there is a change. I'll execute this. Notice the change. Something has changed over here. What is the difference?
Exclusive is not there. Like it is including it.
If you are using, see, it can be performed. You have both the options, zero indexing, as well as you can also you will also be able to use your custom indexing also. But the only difference over here is that will be, of course, this is also inclusive, okay, as well as your stop. Even this will also become what? It will also become inclusive. Means what? So both, basically both start and stop are inclusive, but on the other hand side, zero indexing means start is inclusive and the value of your stop is going to be exclusive over here, guys. Clear, everyone? Remember this point, because here it is, the data is very small. I created the data, we can easily understand it, but once we go into bigger data set now, the same topic will become a little complex. That's why.
Hello. Yeah, this whatever you've given in the chat, I just pasted it, but I'm getting one error. I'm getting some error. Not
What is
getting
the
the
error?
output is first.
What is the error you are getting?
Okay, PD is not defined. I need to import first.
Import pandas as PD. Okay. Now,
Okay.
now I want you guys to help me out. Okay, help me out, guys. See, simple. I need to extract Anuj, Arunima, and Dinesh, but by using custom indexing. Help me to extract this data by using custom indexing. What will I provide? Quickly.
Will be C2E.
That is C2, that is E. Okay,
C
one
column.
question. Will this value be present in my output, or it will stop one value before that?
Both.
Dinesh will be present.
It will be present.
It will be present in case of custom indexing over there. Okay. Okay. Now, so that is how we perform the indexing and slicing in case of series, guys. Okay, wait, before we go to the next part now, give me a minute. I have some two data. I'm sharing to Python list in the chat box. Can you guys copy this one? Or else we'll create a Python list. Just a minute. Let me create it. We have the data. This is our list. I'll even write down location.
Sir, sir, can we give 2:, nothing blank, so that it
that also.
gets all the names?
Default
Yeah, okay.
Yeah, default indexing also will
Yeah,
work.
default. Okay.
This will also work if you want to go until the end. Okay, wait. Let's say over here we have the data list and locations also. Let me put in. We have, I'm from, let's say, Tamil Nadu. Anita, I'll take it as, let's say, AP. Let's say I'll take it Anuj as, let's say, MP. Arunima, I'll just take it as, let's say, JK. I'll take it as Dinesh. I'll take it as, let's say, K. Okay. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I'm sharing this data, guys, so that are the start and stop values inclusive only in case of custom indexing. Yes, only in case of custom indexing. But on the other hand, zero indexing means start is inclusive, stop will become exclusive. Okay, now I want you guys to now help me out, guys. See, I have data, list of names and the locations where these people belong to. What I want you guys to do is basically simple, right? So I want you guys to create a series out of this. So basically I want what? I want the locations to be the index values. Okay, I want the location to be the index values and the values, this data to be the actual values. Okay, I know this is wrong, but again, just for us to work on a small task, that's it. Okay, so the name should be the what? The values over there. Location should be the index values. The name should be the actual data. Then step one. After that, okay, after that, help me to extract the data within this particular range. Okay, or else wait. Help me to extract the data who belongs to this city, this and this state. Okay, so there's two states. Both the things, guys. Create a series and then extraction as well, but by using custom indexing.
So you want to extract the values from Tn to till MP, right? Is that my understanding correct? Isa, are you there? Can someone please tell me what is the problem statement?
We have to extract Tn and MP value.
Tn
from
and
the
MP
series.
only. Okay, thank you.
Okay. Yes, I see many people giving it in different manners. Anita, you're correct. Arunima, this is also correct. Okay, so that is correct, but the thing is you're let's say selecting one value, but by chance 5 to 10 values, na, slicing will be a better option. Start from here, go until here, take the step as 2. That will be a better option. Okay, now let me copy any one of you guys and paste the code. Awesome, right? So run this code out. Let me run this and this one, right? So of course I'm able to extract it, but the same thing if I want to extract this by zero indexing, what will be the values? Start from what, go until what will be the step? Zero indexing, what will be the numbers?
0:3:2.
0, 0, 1, 2, 3, and then 2. Okay, now notice something. This is 0, 1, 2, and 3. We are passing the stop value one value ahead of this one. Why? Because the stop value is exclusive, guys. Okay, only in custom indexing both are inclusive, but in zero indexing start is inclusive, stop will be exclusive over there. Okay, okay, now let us proceed. Okay, now in this data, okay, so now everybody please stop working, focus on my screen, guys. Again, we'll come back to working. Okay, now let's say no, I don't want to create a series at all. My task is to create this data as a form of 2 different columns. Okay, so my task is to create the data into 2 different columns. Okay, so first one, you can give the name of column as let's say name, and this is as location, something like that, right? So how can I do it? This is where data frame comes into picture. Okay, so data frame comes into picture. Okay, now how do we create this data frame? Okay, now let's say over here. Okay, so now see, there are 2 syntaxes I will give you. Okay, so one is complicated syntax 1, and then the easier syntax also I'll give you. Okay, syntax 1. Okay, so this is the lengthy method. If I want to create a series, so basically my target is to do what? I want this data to be, let's say, present as, let's say, names, one column. Okay, the name over here is, let's say, name of the column, I'll give it as, let's say, names. I want this data to be present in the second column, let's say over here locations, something like that, right? So basically 2 different columns I want to create. How do I create it? Okay, so this is the lengthier method now. Okay, so what you can do is pd dot data frame. Okay, data frame is to create the data frame manually, guys, from your side. Okay, pd dot data frame over here. Yes, you can directly go ahead and you can provide this data into a form of a list over there. So this is nothing but our nested list, correct? So a list inside a list over here, right? So now if you want, yes, you can do it like this. Okay, now notice I'm able to create a data frame, but there is an issue. The issue is basically what? So here, over here, what is the issue is basically this whole data got mapped as a single row. This whole data is getting mapped as a different row over there, correct? But my target was to create column-wise data. No? How do I do it? Okay, so now let us try to understand it. But before doing that, question is, how can I give custom index values for these two rows? Okay, what parameter do you think I can use over here? Same parameter, that is index is equals to over here. Okay, let's say over here names I'll give, and let's say the second column name I'll try to give as, let's say over here locations, something like that, right? So this is nothing but our custom index values which I have provided. Clear, right, everyone? Now, because the same thing we have done it in our series now. Okay, after this, now you guys tell me, in NumPy also we saw which function helps us to convert rows into columns and columns into rows.
Transpose.
That is transpose dot t, right? Now run this code out. This is the target which I wanted. I'm able to achieve it. Okay, now wait, let me repeat it again. So what did I do? Why did I play around with this one, right? So now the over here, okay, so if you remember NumPy also, the same concept we saw over there, right? So it is nothing but a nested data, right? So over here, this is the data. So I am trying to do what? PD dot data frame. Okay, so over here I'm providing the what, the LST and then the location, right? So this is nothing but our nested data, a list inside a list. Right? Notice over here also same thing we saw, right? So in our NumPy also we saw the same thing. This whole thing we refer it as one single row, correct? This whole thing we refer it as the second row. Same concept over here also. Notice this whole thing will be created as a row. This whole thing will be created as a second row. Notice that is what has happened over here. Okay, now what did I do? I am now giving custom index over here by using something like this, custom index, and let's say names over here, and let's say second thing I'm just giving it as, let's say over here location, something like this, right? Okay, locations. Now once done, so what will happen? I'm creating, or basically I'm creating a data frame, this as a row, this as a second row, and I'm giving custom index values for these each rows over there. Step one. Then after that, now I'm doing what? Nothing but transpose, converting rows into columns and columns into rows. This is one of the methods. But is there any shortcut method? Is this the lengthier method which we need to follow? The answer is not at all required. Yes, syntax one is also useful, but it is, if you look closely, multiple things, right? So one is the list of the each rows. Then again, then I pass the custom index values. Then again did a transpose, right? Similarly, let's say you have a data, 50 columns are present, 50 times you have to do the same thing, right? So it will be an hectic thing. Is there any easy method? The answer is yes. How can I do it? Simply, you can create it as a form of a dictionary. So dictionary, okay, how? Let's say over here, the keys will be picked up as the names of the columns. For example, let's say over here names I'll give, okay? So name, okay. Similarly, what is the value which I need to assign? That is the LST, okay? This is the key and the value. Similarly, second thing, right? So that is locations, okay? Locations. Over here, LOC, right? So run this code out. You'll be easily able to create a data frame out of this data using a dictionary over here. Syntax 2. Clear, everyone? Any questions?
Can you explain one?
Syntax 2, simple. Just
Yeah.
passing a dictionary. Syntax 1 is nested list, then changing the index value, and then again doing a transpose and everything. Okay. Now try it out, guys. Okay, wait. You'll get this clarity only once you're working on it. See, now I'm sharing this two lists into the chat box. Simple case. Create me a data frame out of this. That is okay. So basically, I want, but just for learning perspective, now try to do it in both the syntax. I want you guys to give me the code in both syntax 1 and syntax 2 as well. Okay. So what is the target I want? I want the name of the column as, let's say, country. Okay. Whatever value is over here, that should be assigned in one column. Second, right? So that is currency, right? And then whatever values over here, that has to be assigned over here. Give me the code in both the syntax 1 and syntax 2 as well, quickly.
Sir, could you please scroll it a little bit up?
Okay, as a reference, I'll keep this two code over here. Same thing, I just need to change some things, so that's it. Quickly. For learning perspective, try to give me the coding, both the syntax 1 and 2 as well, so that we'll never forget this point at all.
Sir, I have one question. Can you go to row number 27? 27, sir. There. 27 or 28?
And this one,
Yes, sir. That 27. Yeah. This 0:3:2 is the step, sir.
Exactly. Start, stop, and then the step value.
Okay. Okay, sir. Thank you.
Okay.
Sir, can I just share my screen for 1 second? I just want to
Share what, Kushal?
screen. Share my screen.
You want to share the screen?
Yeah.
Quickly share the screen.
Yeah.
Import pandas as
Yeah,
PD.
just here only I need to write input.
Yes, import import.
Import.
Import space pandas and as PD. That's it. Run this code. That is cap. Wait. No module name. Okay, pandas space pypi. Install this one. Open new tab. Okay, RS in a new cell, na? You just write down pandas space pip install pandas. Pip install pandas.
1 minute. What did I do then? What should I write?
Pip install pandas. Execute this one. Yeah, this will get downloaded. Once done, you can run the above code. Done, Kusha?
Yeah. Then I have to.
Yes. Remember, I started my class with this one. You have to first import this tool in order to work on it.
Okay.
Okay. I hope everybody has given me the code. Perfect. Okay, so.
Yes, sir, one question. When we use the data frame as this dictionary form, so by default it will take as a transpose.
Exactly. By default, the keys will be the names of the columns, and whatever values which you have assigned, that will be the data out there. Okay, so see over here in this case now, by default the keys will be the names of the columns, whatever which you are providing. Okay, and whatever values which you are providing, that will be the actual data over there.
Okay, so it is taking a default as
exactly.
row and column.
Okay. Now one more data I'm sharing, guys. Okay, so I'm sharing one more data. Now what I want you guys to do over here. Okay, so this is the data now. What I want you guys to do is basically create a data frame. Okay, so create a data frame in such a manner that I want year. Okay, so I want the year column to be present. Then two countries now. What can I write down over here? Host country, I'll write down host country. Wait, I'll write down in the below hand side. I want the data to contain the columns such as year, then host underscore country, and then third column name we'll keep it as, let's say, the winner country, and then the goal scored. Okay, so create a data frame out of this one which contains this particular column names and whatever year is present, right? So this value should be assigned to this year. Whatever values which you are able to see over here should be assigned to host country. Whatever values which you are able to see on the third location should be assigned to the winner. and then this one should be assigned to the goals code. Okay, now here I'll give you a hint. How do you solve this? For you to solve this one, you have to use columns is equals to, instead of index is equals to, no, you'll be using columns is equals to. That is the only difference.
Sir, could you paste this in chat? Okay, yes.
Okay, I have pasted it. Again, let me paste it. I have pasted it.
No, yeah, I got it. Thank you.
Done. Yeah, actually, I'm spending some time to understand to create data frames, guys. Why? Because loading the data is very simple job. The problem comes is when you're creating the data frames manually, right? Only then the many problems arises. That's why I'm just spending some time over here. Try to understand this. You're correct. Others try it out. Only difference over here is you'll be giving columns is equals to, that's it. Okay, so let me copy any one of you guys' code and paste it over here, run this code out. Awesome, right? So we are able to create the data frame like how we wanted. Okay, now second thing, now I have a dictionary directly present. Okay, so now I have a dictionary directly present. Now I just want to create a data frame out of this one. Okay, so now the question for all of you guys now, can I directly pass this df underscore dictionary? Yes or no?
We can pass it.
Achha, what will be the names of the columns? Will it be 0, 1, 2, 3 as a default column names, or whatever column
0,
is
1, 2, 3 will be the default column name. The row name will be year, country, winner, goals code.
Think. This is dictionary. How we saw over here.
The keys are
I
the
think
names
the
of the
keys will be
columns.
the
The
name of the
keys will
columns.
be the the keys will be the column names, and then whatever values which are assigned, that will be assigned as the data. So like how we saw over here, right? So the keys becomes the column names if you're creating from a dictionary, right? But if you're creating like this, yes, what we are telling is correct, right? So this will be one row, second row, third row, like that, right? Then again, rows or columns we need to play around. But in this case, it is going to get directly mapped as column names and then the value over here. Okay. Now let us proceed, guys. Okay. Now there is a problem. Okay. Please, everybody stop working. Let me now come back to the problem. All of the methods which I actually did now, it will only work in what case? It will only work if all the values, all the arrays, see every single row, this row contains 4 values, every single row contains, every single column contains 4 values. If one small mismatch like this also happens, right, this code is going to fail. Okay, so notice now it is going to fail, telling that, hey, all the arrays should be of the same length. Okay, that is why you have this particular failure now. Okay, see all the methods, whatever method which we have done, right, it will only work if all the values, the length are same. Okay, now the question is, how do we resolve this error? Okay, two methods, two solutions I can provide you. One is the wrong solution and the second one is the correct solution as well. Okay, wrong solution, this is the wrong solution. Okay, so what if, okay, yeah, I understand the data is missing, right? So I don't know what is the goals code over here. I cannot randomly put anything as well. What I want my system to put over here is, let's say default, I want it put it as null value over here. Now, can I ingest null values? The answer is yes. How? What you can do is, instead of directly mapping this Python list, Python tuples like this, now do one thing: convert each value into a series. But I know this is wrong method. Okay, I'll show you there is a problem with this method as well. Okay, So instead of directly mapping your Python list or a tuple, you do one thing, that is you convert each of this particular data into a series, something like how I'm doing it, series, and then map it. Okay, so now what will happen if we do this one? Let us try to see the output now. Okay, so instead of directly mapping, just one changes, I'm converting everything into a series and then mapping it over. What happens in this case? If you are doing it like this, now notice something. By default, it will automatically try to maintain itself as a type of a what? As a type of a rectangle. Okay. So if any particular column has data mismatched over there, right? So what it will do is it will ingest all the places where and all it has a mismatch. Let's say 5 values are mismatched by it. All the 5 values, it will put it as null. Okay, so NaN is nothing but our null value in that location. Okay, so that is what pd.series will try to do. But this is the wrong method. Why I am telling this is the wrong method? Imagine another scenario. What if, let's say, the data was 161? Okay, what if the data was Brazil is present, but for France the data is missing? Now the question is, can I leave anything blank like this in case of our core Python? Answer is no. That directly gives a syntax error. Okay, now can I remove this one? Can I just pass like this? The answer is yes, you can actually pass it. But what will pd.series do? See, this data was actually present for what? Brazil. But where it has mapped over here? Is it correct or it is wrong?
Wrong.
What is wrong? I don't have any error at all, I don't know.
Map to a different country.
Mapped to a different country. Here the data is at least very small. We can even correct it, right? But imagine if the data is very huge. Literally, this becomes a hectic thing over there, right? So what or how do we actually resolve this? So what happened over here? This 161 was for Brazil, but this went for France over there. Notice it was for Brazil, it went for France. So that is an issue. So what we can do over here is in this type of scenarios, okay? So do not directly do it like this. If you have null values in between now, then try to use our Python null over there. Okay, try to use our Python null at that location. With the advantage, what will happen in this case? Whatever location null value is present, the same location it will get mapped over there. So yes, before creating a data frame, the thing what you need to do is basically you have to first clean the data and bring the data into this format. See, why I'm telling you have to clean the data, because your data is very small. I'm able to do it in one single shot. 1 million rows, right? You have to run a loop, you have to think of a logic, and then you have to first get the data in this format and then convert it into a dictionary, data frames over there. Clear? Everyone?
So here data is small, that's how you could replace none, or we can do that with
If
programmatically.
the data is, yeah, that is why you have actually studied core Python this much. You need to first think of a logic, run a loop, something like that you have to do and bring the data in this format. Then itself you map it over there. Clear? Okay, now, okay, so that's why, right? So I actually spent some time on creating data frames, because while creating you have to struggle many things, right? So you have to think of null values, where and all, whatever it is, right? You have to think of many things. But what if I want to load the data from an external source? Let's say, for example, from an Excel sheet, or else let's say, for example, from an CSV file, or whatever file, right? So can I do so? The answer is yes. That is pretty simple over here. Okay, so let's say over here I have a CSV file. I want to load the data from here, or else let's say I'll even show you with an Excel file also, because I have both of these type of files as an example. Okay, these two files, right? So these two category of files, or any other category of file. Can I load the data from any other source? The answer is yes, you can do. How? So pd dot, just write down RE and press tab, guys. Everyone do this. You should be able to see multiple options over here like this. How I'm able to see? Press RE and press tab. Okay, so what are these options? See, I'm just showing you this CSV and Excel sheet, right? But the thing is, you don't have only these two options, okay? So you have actually couple of other options as well. See, different, you can even load the data from a clipboard. If you scroll down, see, from an HTML file also, you can actually boot the data directly from a JSON file, from your Oracle file, from our Parquet file, right? So from our Parquet files, from our Pickle file, deployment files, from your SQL query table, from your SQL query, right? So you have multiple options from your XML files, whatever it is, okay? So depending on what type of data you are actually working on, okay? So in this case, let's say, for example, I want to load the data from an Excel sheet. This is the function I'll be using. From a CSV file, this is the function I'll be using, okay? So that is how you decide which function to use, guys, okay? Now, step one, once we decided, okay, which function to use. Now the thing is, for you to load the data, you can give two things over here. One is your complete absolute path, okay? For an example, 1 second, I'll do one thing. Let me share my complete screen itself. Okay, so for an example, let's say I just want to, this is an example, right? applestocks.csv. Okay, so this is the file I want to load. Now here you have an option to do what? You can actually pass your complete absolute path as well. Okay, so let's say over here, go to properties. Here you can actually copy the absolute path like this. Okay, so you can pass this one as well. Okay, let me try to show you while working on it, right? So pd.series from here, this path, okay? So basically your complete absolute path, okay? But there's a problem. Try to convert this either into a raw string or use two backticks, guys, okay? So use two backticks. Why? I'll try to show you with an example, okay? So try to do it like this. And then after this, over here, I needed to get inside one folder, right? That is dataset, then name of the file. That is, what is the name of the file I wanted to load? I wanted to load this particular file. Let me copy it. Okay, so from here I need to get inside, and then this is the file. Okay, so what I'm trying to give is, yes, you can give your complete absolute path like this, or easier method, you can also give your relative path also. So let's say read CSV from here. See, right now my Jupyter notebook is in this folder. That is 8th November 2025. That is over here. My Jupyter notebook is over here. From here, I just need to get inside datasets folder and then load this file, correct? So now what I can give is from here, just get inside dataset folder and then the file name. That is applestock.csv, right? Run this code out. Both of this is possible. Your absolute path or your relative path as well. Clear?
Yeah.
Okay. Okay. Just out of curiosity, any idea why I'm using R over here in everybody?
Escape character.
Yes, escape character, and then this is called as something called as raw string, something called as raw string. In core Python it is present. Okay, 1 second.
Great.
Imagine one thing. There are some special characters in our Python, right? So let's say over here A is equals to. I'm just going out of topic. I'll come back again. I just want to give this so that everybody has a clarity, guys, why we are using that one now. So in case of Python, there are some special characters like /n, /t, right? So /n is what? /n is what? /t is what?
Comes to next line and /t comes
tab space, right? See,
yeah.
/n is the new line. /t is nothing but our tab space between world and Python, right? So that is what we are able to see over here, right? Now, so there are some special characters like the /b is many characters are present. Okay. Now I don't want to get inside the details. Now, let's say over here, I don't want the function to take place. I want this to be considered as a character. Any idea how I can not allow the function to take place?
Raw string.
Raw string, or you can add one more backslash. This is called an escape character. Right, one more backslash. What will happen? The advantage is, notice now /n function did not take place. It did not, hello and world did not go to a new line. It is in the same line. Why? Because I did not allow the function to take place. Okay, that is what this escape character. That's why I told you either use R or use two backslashes like this, because this is an escape character. Okay, why raw string I used? Because see, let's say over here like this, there are 100 functions. Literally every 100 functions you have to sit back and again keep on writing this one, right? So escape character in all of the characters, right? So that will become a hectic thing, because see, /n function did not take place. /t function has taken place because I did not add escape character over here. Imagine 100 characters like this. It will not work fine. So that's where what I can do is easier method. Just convert this into raw string. Write down R before the string. Let it be even million functions like this. None of the function will be allowed to take place in the complete string. That is why raw string we use. Okay. Now, why did I use that into the path? Imagine you're opening something like this, that is users. From there, let's say over here new folder, okay, and then let's say over here you have a test folder, let's say over here you have test folder, okay, so folder, something like all of this now. So if you have something like this data, okay, then there is an issue over there, right? So what is the issue? /n is there, /c is there, all of these functions will take place, right? Just to avoid that functions, we are using something called as raw string over here, guys. Clear?
Okay,
Clear, right?
yeah. One PWD works in this, is it? Like PWD?
Yes, your Linux commands also works, because this is actually running in your Windows terminal. This will work. PWD, LS, all of your MKDIR, everything will work.
Okay.
Okay. Now Excel sheet. Okay, now you guys have to help me out. I have an Excel sheet. Which Excel sheet? Any one random Excel sheet. Football World Cup Excel SX. Help me to load this particular file. So which function do you think I need to use? RE, read CSV, correct or wrong? I need to load an Excel sheet.
Excel, read underscore.
Read Excel. Okay, read Excel function. After this, now yes, you can give the complete path, that is C drive, whatever it is, right? So you can give that one, or else from here datasets. From there, I need to get in, open what? Football World Cup, right? So football Excel SX. Okay, now run this code out. You'll be able to load the data. Let's say over here, no, if you want to read a specific sheet, let's say there are 5 to 6 sheets over there, right? So here you have an option, guys. Sheet name is equals to sheet 1 or something like that. You can give like that option as well. Okay. So you will be able to load the data. Okay. Now let us proceed. Now, before we now we understood how to create data frames manually. We understood how to load the data from an external source. Now there are some basic functions, Pandas basics. Okay. Some basic functions which will give you some insights of our data. Please stop working, guys. Focus on my screen now. Everybody, please focus on my screen. Okay, I'll take any data as an example. Let me take this itself. Now, there are some basic functions that help you to get some insights of our data. Okay, so wait, let me take a little huge data. This one itself, let me take. Okay, df is equals to this one. Okay, so this is the data. We have totally how many rows? This is a total number of rows. Okay, so the first function I'll introduce you guys is something called as info. Okay, so info. Now we have different data types. String we have integer, we have float, all of this XYZ data types, right? Now I have a simple question. Okay, this date column over here, what is the data type? Is it actual data type, or is it a string right now? If I want to find out whatever data, right? So over here in this case, what are all the data types for each column which is present? How can I find out? That is where .info comes into picture. It will give you the, okay, what all things which we can read. Let us understand this, right? So this is the output which you will get in case of info. Understand the output. Totally 129 entries means what? There are totally 129 rows inside my data. The index value starts from 0 to 128. That input I got it. In my complete data, totally how many columns are present? In the complete data, there are totally 6 columns which are present. Okay, so in this particular data, there are totally 6 columns that are present right now. That is what and all columns, if you ask me. See, we have date 1, 2, 3, 4, 5, 6. 6 columns. Okay. Each column, what is the data type? See, in case of pandas, you do not have string, anything called a string. You have object. We refer it as something called as objects. Okay. So object is nothing but string itself in the backend. Okay. So we have objects, and each column, what is the data type, you can find out over here. Then, okay, but there is a different function that will give you more insights. But here, in a glance, you can have in the complete data how many not null values are present. See over here, 129 out of 129 rows, 129 not null values are present. What is the meaning of this? How many null values do you think it will contain?
0 null values.
0 null values, right? So how many null values in each column? But there is a different function. You get more clarity over there. Use the other one, but in a glance, you can have this one. Okay. Then in the complete data frame, there are 4 float data types, 1 integer data type, and then 1 string data type over there. That inputs you can have, and then the memory occupied in your RAM right now. How much memory it has occupied over there, right? This is very critical when you are dealing with huge data, especially in our PySparks and all. We'll use this one, right? So what is the memory occupied in our RAM over there? So these details you can get it inside your info. Clear? Okay. Now step function 2. Okay. So one quick question before I continue this. Again, am I going too fast today as well, guys, or is the pace okay?
It's a little bit fast, sir. I want it to be a little slower than this.
More slower? Okay.
Yes.
Okay. I'll reduce a little bit more. Huh? Okay. Now, second function. Okay. So second function is basically what? Head. Okay. So head, right? So head is what? Anyone who has worked in SQL.
So can you please explain that info part again, that non-null, if you don't mind?
Okay. Now imagine this over here. Okay. So totally 129 rows are present in my data. Okay. So okay, imagine there are 5 rows inside your data. Okay. So here I have something like this. Here I have a null value. Here I have 4. Here I have 6. And here I have null value. One question. How many null values are present inside this particular column?
2 null values.
2 null values. How many not null values are present inside this column?
3.
There are 3 not null values, correct? So this will give you the total count of not null values present inside my data. Clear, Vinay?
Okay.
Okay. So see, out of 129 rows, 129 not null values are present. What is the meaning of that? How many null values do you think are present in date column?
No null values. Okay.
Understood? So all of this 129 means there are no null values in any of the columns out there. Okay. Okay. Now head is what? So one question. The people who have worked on SQL, limit
column names.
4. No, limit 4. What do you think will give you this?
Will give you 4 records.
First 4 columns.
First 4 rows of your data.
Yeah.
Correct? Okay. Now, in case of pandas also. Okay. In case of pandas as well. See, if you look closely, this is the functionality of Jupyter Notebook actually. So it is by default displaying you top 5 and last 5 rows. Okay. But if you are using VS Code and all, this will be visible in a different manner like this. One second, I'll show you how will it be looking like. It will look like this type of data. Okay. So over here, if this is a data, so if you want to look at the top 5 rows, or let's say top 2 rows, or top 10 rows, or top 20 rows, is it possible over here? The answer is yes, that is possible. How? df.head is the function. Okay, see, head function. Like, unlike SQL, there is no default value over here, correct? So there's a default value in your order by. By default, it will try to sort it into ascending order. If you want, then you need to change it into descending, right? Here, there's a default value. By default, it will display you the top 5 rows of my data. There's a default value present. Let's say, no, I don't want that. If I want to only look at, let's say, top 10 rows, or let's say top XYZ row, right? So can I provide any integer value with it? The answer is yes. You can provide it, right? So this will give you top whatever number of rows which you are providing. Let's say top 20 rows I want, you'll be able to see it. Let's say top 50 rows, top whatever number of rows you want, you'll be able to only pinpoint that type of rows over here. Okay, step 2. Opposite of this is also present. But in SQL, you tell me if this is present or not. There is something called as tail. Okay, so like head, it is displaying as a top XYZ number of rows, correct? So let's say top 10 rows, top 2 rows, or whatever, right? Let's say if I want to, let's say, see last 2 rows, last 3 rows, or last 1 row, can I achieve that? The answer is yes. Here tail you can use. By default, this will display you the last 5 rows inside my data. If you do not want this, you can go ahead and you can pinpoint, let's say, the last 3 rows inside my data. This will help you to pinpoint last and the beginning XYZ number of rows inside my data. Clear? In SQL, anything like this is present or not?
No.
Yes.
No.
There is, no.
Hey, unless and until you do not do order by,
Yeah, you don't get that.
you will not achieve this. Okay. So head and tail, guys, very simple. So head is top, tail is bottom. Okay, so these are the only 2 functions. Okay. Now let me proceed. Okay, so we understood info, basic insights of our data, head and tail. Now we have describe. Okay, we have described. Now understand this. Stop working, guys. Focus on this now. In this data frame, that is this particular data frame, how many numerical columns are present? 1 second, I'll give .info. In this data frame, how many numerical columns are present and how many categorical columns are present? Anyone can answer this?
5 numerical and 1 category.
5 numerical and 1 categorical columns are present over there. Okay. So df.describe will give you the basic statistics. See, you have functions. You have to use those functions. That is mean, median, mode, whatever functions. You have to use those functions. Okay. In a single glance, I'm telling. Okay. In a single glance. If you want to, in a single shot, okay, hey, give me some basic statistics of this data. If I want to achieve this, can I do it? The answer is yes. You can actually do it. df.describe will give you the basic statistics. If you want in depth now, you use the other functions, okay? But this will give you the basic statistics of the data. Okay, I'll do one thing. I'll change the data. I'll use the other one because there are less number of rows over there. Apple stocks, no? Not this one. This one I'll use. I'll use this data so that I can explain this in an easy manner. df is equals to this one, football World Cup. Okay, so basic status. Okay, see over here in this data, totally how many numerical columns are present? If you see in this info, year is 1 column. Okay, so I'll display the data frame also over here, df. Okay, so year is 1 column, and then we have goals scored and then matches played, these 2 columns also, right? So these are the numerical columns. This df.describe will give you the basic statistics of only the numerical column. Achha, what all basic statistics will we have? It will give you the total count of the values. How many records are present? Step 1. Second thing, the mean. Mean means what? Any idea? Average of the data. Okay, so the average of the data. So let's say sum of all the goals scored divided by the total number of values. Okay, then again we have something called a standard deviation. I'll not get inside this details because this you will understand in your statistics. It will give you the standard deviation as well as the quartiles. These are referred as something called min and max, min and max, and then the quartiles also will be able to get it over here. Okay. What are the quartiles and all? I will not explain. You will have more clarity in your statistics classes, guys. Okay. So basic statistics in a single glance you will have over here. df.describe. Okay. One thing I think you can actually do one more thing. For categorical columns also you will have basic statistics. Let's say in this case now, you'll have statistics. What are the statistical values which you can achieve from here? We will be getting something called as mode. Okay, what is mode? In case of this one, right?
Most
What will be the
frequency?
Any value which has been repeated the maximum number of times, correct? So for an example, I think for this column, right, Argentina, notice 1 and 2. Okay, so this will be the mode for this particular column. How many times it is repeated? It is repeated 2 times, right? So in describe now, if you want, you can actually give include is equals to which data type, that is object, right? So you can actually include this one. You will have a basic statistics of categorical columns also. 3 columns, right? So 3 columns, categorical columns, statistics also I'm able to see. But here the output will be different. It will see, you tell me logically, can I calculate mean for this type of data? Not at all possible. How will I calculate, right? For numerical values, it is possible. But for this type of values, mean and all, quartiles and all, it is not possible. For this type of data, we calculate something else. We calculate what and all? Count how many records are present. So there are basically 7 records. Okay. Now in each column, how many unique values are present? See over here, there are 6 unique values. There are only 6 unique values. Means what? I think there are 2. Brazil over here is repeated 2 times. Brazil over here is repeated 2 times. In this case, Argentina is repeated 2 times. Okay. How many total count of unique values inside my data? Okay. Then over here in the below hand side, this is the mode. Brazil has been repeated the maximum number of times. How many times it has been repeated? It has been repeated 2 times over here. Okay, so over here, Argentina has been repeated 2 times. Okay, what if there is no mode? See here, there is no mode at all. Because Italy is not just this, there's no value which is repeated at all, right? So in that type of scenario, what will be the output over here? The first value, the first row, and then the count over there. That's it. That is what the output for your statistical columns will be provided. This is in one glance you are having it, but there are functions for each of this separately. In a single glance, basic statistics of numerical columns and categorical columns, it is possible for you to achieve. Clear?
Can you please repeat this include equal to object means this 80 to 8? Yeah, I didn't understand it.
Okay. Now, okay, let me repeat it, right? So here we have the data. df.describe. It will only by default give you only the statistics, basic statistics of your numerical column. That is what and all. Year is there, goal scored is there, matches played is there. Okay, but no, I don't want that. I want for categorical columns, basic statistics. In a glance, I need to understand the data, right? So what can I do here? You have a parameter. Include is equals to, that is what over here. What is the data type? That is object, na? So if you see the data type for this columns are object. Objects are nothing but string, correct? So this data type, I'm just providing it over here. Okay. Now what will it provide? Will it again calculate count, mean, standard deviation, quartiles, min, max value? Will it calculate that? The answer is no. It will calculate something else. It will calculate what and all? It will calculate the count of the data, the total count of the unique values inside my columns, each columns, and then the top value. Top value is nothing but the mode, the maximum value which has been repeated the maximum number of times, right? The mode. If there is no mode, first row itself it will calculate. It will provide you over there. Clear? Okay.
And
okay.
Frequency means?
Frequency means Brazil is repeated how many times? It is repeated 2 times.
That top frequency. Okay, top ones.
Yes.
Okay,
that is the output which you'll have over here. Okay, 1 second.
One thing, like why the top is different? Like for example, the top means top element should come in, right?
Top
the row is
the first
defined.
value.
Yeah.
First value? No, this is not the first value. This is the mode it is calculating it. Okay, so if you want the first value, yes, you can achieve. You can only capture the first row and then you can capture that particular column. But this will give you what in statistical, right? So it will not give you the top value. It will give you the mode of that particular column. If there is no mode, yeah, then what you're telling is correct. The first value in your complete data. That is what it will provide. Clear? Okay. And now, wait. I'll load some other data set and I'll come back to the same question over here, guys. Okay. DF is equals to, everybody load this one because we'll be working on a bigger data set now. That's why. Okay. So read CSV file, I think that is. From here, city bike trip data. Okay, so everybody load this data, guys. Okay, so I'm sharing this data set in the chat box. Load this data set. Okay, now over here, df.info. First question. Now all of you guys have to answer me this one. What details do you understand from this one? What all quickly? Just a summary.
32,428 rows, like entries are there.
Entries
How
and
many
data
columns? How
types.
many
10
columns in the data
columns.
frame?
10 columns are
10
there.
columns.
And
Each
all
column,
are, each column is
Values
having
range.
non-null values.
exactly. There are no nulls in the complete data. Then totally, how many string columns? How many
Categorical
6 string
6 and
columns
numerical
and
4.
4 entries.
numerical columns are 4 over there? Okay,
4.
so now done. Df dot describe. Okay, so it
Sir,
will now
one
give you.
question. Hello, sir. One question. If null will found in the data, for example,
So let's say there are two null values, na?
yes,
So
yeah.
300 and 32,400 and something like this. So this
Yes.
value minus 2, it will give you.
Okay, okay. And how to handle that null value?
That will come different function.
Okay, okay, no problem.
Okay. Now df dot describe. First question. How many columns output will I have over here? All the 10 columns, or only 4, or only 6?
Only 4, because only
It
the
will only
integer.
give you the default numerical columns. Okay. Now let's say over here, I'll give, let's say, in this case, I'll give, let's say, include is equals to, what is the data type? That is object. Okay. Now, one second, df.info. I'll bring that over here as well. Here, there are 6 object columns. What will it give over here? This output. For how many columns? 10 columns, 4 columns, or 6 columns?
6 columns.
The output will be for 6 columns. Okay. Now, okay, simple words. What is the meaning of this 2? What is the meaning of this 2? Unique 2 means what?
There are 2 unique values in that column.
Inside the complete data. Well, there are 2 unique values inside the complete data. What is this subscriber and what is this number?
Number of times it has repeated.
How many times subscriber is repeated over there. So understood, right? Everyone now clear, na? Okay. Now let us go ahead. Okay. So break. Bhavna, let's continue, na? We'll have break at 11. Okay. Or else, everyone, do you guys want to have a break, or before we start this indexing and slicing, or shall we continue? What about others? Bhavna wants a break.
Yes, break.
Just one more thing. If we want all the columns, then object and integer both.
Then there is a method, but do not use this because you will get confused. In a single shot, if you want everything now, you can actually give include is equals to all like this. But it will be too confusing. Do not use this type over here. Okay.
Okay.
Okay. Then we'll have a break and then we'll come back, guys. Okay. So, what is the time now? 11:38, 11:40. Let's be back in 10 minutes. Done?
Yeah.
Okay, be back by 11:50, guys. Okay, be back by 11:50. Try not to miss this topic, because if you miss this now, then again working on pandas will become very hectic for you guys. That's why.
10:50. 10:50.
Sorry, 10:50. Be back by 10:50.
Okay. So Afra, like during the break, I'll just take 2 minutes of yours. Is it okay if I share my screen?
Yes, I should. Go ahead.
So I ran into this problem. I just imported PD again. It fixed the problem. But when do you run into this problem?
DataFrame has no object. Okay, what happens, right? So DataFrame. Okay, you have actually done what? You have actually stored the data into PD. Okay, so I'll show you one thing. One second. Give me control, Ashwin. No, share the screen. I'll show you over there itself. Okay, now let me take the control.
Yeah.
Can you? Check this. Okay, I'm able to have the control. I'll just do it in the different cell so that all the keyboard shortcuts will not work. Okay, so imagine now, let's say over here I have a data. Okay, let's say over here this is equals to okay, I'll give like this, right? So you have, let's say, print. What is the job of print? What will print do?
Print outputs a string.
So print, the job of print is to what? So print, let's say A, if I give, it will print the output over there. Basically, the outputs into the screen. That is the job of this. But what can happen is print, you can, if I assign this into a value like this. Okay, so now what happened? Now print function is lost now. Now what is there? Now it is now print is a value now. It is no longer a function. Okay, so print plus 1 if I give plus 1. See, now 10 plus 1 will be the output. Same code which worked earlier, this code will not work now. Okay. Now why is it not working? Print was supposed to work, right? Because what we have done is we have replaced the existing function of print. Okay, that is what has happened now. Okay, now wait, let me now delete this. Okay, let me delete this. 1 second. Now I'll come to your question now.
Print is a reserved keyword, no? Can you do that?
Print is a built-in function. It actually does not comes inside the reserved keyword.
Okay.
Okay. Now coming to your question. So yes, what you did is import pandas as PD. You did it. It will work fine. Okay. So then let's say, but what somewhere in the code now, what you have done is, can you copy? Are you using Mac?
Yeah. Control C.
Okay. Command C in my case.
Done.
Now, what did you do is PD is equals to this one. Okay. See, it worked actually. Now, what happened? Now, PD contains what? Does it contain pandas or it contains the data over there? The data frame. It is a data frame, right? So that is what has happened in your case. Okay. So now what you do is, I'm deleting this.
Yeah.
I'm deleting this. Please restart the kernels and once again import everything, Ashwin.
Okay, perfect.
Okay, done.
Yeah, got
so
it.
do not do that one, huh?
Yeah. Maybe it is because of cargo coding.
Somewhere you might have done that.
Yeah.
Somewhere it is done. PD is equals to you have assigned that.
Yeah. I think I have done that role. Maybe here somewhere. Yeah. Yeah. Thank you.
Done. First question. So if I store this into A, what do you think the data type of A is going to be? Any idea? Anyone who can answer this?
Series, I guess.
Exactly. That is going to be series data over there. Okay, that is the series structure over here. Okay. Now, so like this, you can pinpoint one column. If let's say there is a task, I will need to only work on one column. Yes, you can go ahead and you can capture it like this. Let's say no, my task is to do something. Let's say my task is to work on two columns. Let's say trip duration and bike ID. Okay, so can I select two columns or three columns like this? The answer is yes, that is also possible. What you need to do is simple. You just need to pass multiple columns into a form of a list. So let's say here you want to work with trip duration also, or else let's say bike ID along with this one. Let's say two columns. Let's say not just two, I'll even pull one more column along with this even user type also you want to work with. Well, it is three columns I want to work with. Can I pinpoint this? Yes, you can pinpoint how into a form of a list over there. You can go ahead and you can select it. Notice I'm able to select only those columns. Okay. Now, next thing. Okay. Now over here, okay. So I'm able to select column level. Clear, right, everyone? How to select column level? One column or multiple columns. That is also possible. But what about row level? That is row level, right? So only first from here to next three rows, from something like that, right? Row level indexing or slicing, or else let's say forget about row level. What if I only want to capture a value? Let's say over here I need to extract this particular value. City hall I want to extract. How can I achieve this part over there? For you to achieve this one, okay? So 1 second. The file name is this one here. City bike trip data. Let me copy and paste it in the chat box. Okay. So what I'm trying to tell is, let's say Columns we understood, the whole column we are able to extract. One column we are able to extract, right? But what about one single value? Let's say this itself alone I want to extract. I want my output as city hall. How can I achieve this? So that you can go ahead. That is also possible. Two-step process. Okay, remember in our core Python also we did this one. So one is first extract the data for the column level like this. Then after this, what is an index value? So see over here, I wanted city hall, right? What is a row level index value for this one?
1.
1, right? So now after this, you can go ahead and you can pass 1 over here. Okay, see, in simple word series also, it is possible, right? Index initializing, we did it in just few times ago when I started this one, right? So in series also it is possible. So like this, you can go ahead and you can extract that particular data. Okay, now for an example, let's say if I want to extract this SIP AVE, right? So or else let's say I need to extract this annual membership. How do you think I need to extract quickly? I need to extract this annual membership. What do you think I need to pass? DF of
Name localized
Name
value.
localized value.
that is the column name, that is name localized value like this. DF of this particular column name. After this,
4. One more
then
index we have
after
to give
this
4.
another square bracket and then 4. Okay, this is the step wise. Okay, this is how you will be extracting the data like this. Okay, but do not use
How
this
we
one.
got 4? Sorry, how we got the 4? I mean,
That is row level index value is basically what 4 for that one, right? So that is what I'm providing it over here. Column name and the index value for that particular value. Okay.
Can you mention first row, then column?
First columns, then rows. No, first rows you cannot do it like this. There is a difference in type. That comes in a different method, Aruni. Okay.
Okay.
First columns and then row level index value. But do not use this method at all. Why am I telling do not use this method? Okay, please use a different function which I'm going to show you now. Okay, why? Because imagine now your task is to not just extract the value, your task is to replace the value. For an example, let's say this, I'll take this as an example. Trip duration, this 190 is there now. I need to change this to 200. Okay, so that is my task now. That is my target. So I'll do it with this particular syntax, like this df of what simple, right? So I'll pass the column name and then what is an index value, that is 3. I'm able to extract that 190. I am trying to do what? I'll try to replace this particular value. Okay, now I have executed it. There's no error. There is a warning over here. Warning is basically what? Hey, your code is basically what? Whatever code which you have written, that code is actually trying to change something inside the data. See, we will not only extract the data, correct? What if we are replacing the data? This type of warnings will come into picture. Notice, see, but actually the value got changed. But with a warning. If you don't want this one, you have a simple function. Try to use the function at over here. Okay, so at will help you to do what? So the syntax of at is what? Same thing. Let's say right now it is 200, right? I need to change this to 300 as an example, right? So df dot at. Okay, here you provide the inputs. So first thing is the row index value. The row index value is basically what? That is 3. And the column name is basically what? This is the column name. Okay, so using this also you can extract the data, as well as you can go back and replace the value also over here. But the change is what? See, right now from 200 it should have been changed to 300. Notice it has been changed. The advantage of this is what? Basically we are using a function that is prepared to do this. See, that is the above one is actually what? It is an unconventional method. We are trying to first extract the data as a form of a series and then again replacing the value, right? So that value will change in both the methods, but with a warning over here. This is an unconventional method, but please use the function that is prepared to do this. That is df.at, but the change over here is first the column name in the above hand side, here the row index value. Then the row index value, here the second thing is column. That is the only difference in using something called as at over here. Clear? Any questions?
So do we have any
This is
function to find a value? I mean, is it there in this?
Yes. That I'll go step by step as if because
One thing here changed. We are using row first, then column. So far, we are using column first, then row.
exactly here the change in the syntax is first the row index value, then the column name. Okay.
This is only for replacement then.
Replacement as well as capturing also. Please use this one itself. For extracting the data also use this particular function. It is very simple over here. Okay. Now coming to the next part. We understood how to extract one column, multiple columns. We understood how to extract one value and replace that value. That is what we understood until now. Now I have a different task. The task is what? Let's say no, that is not my task. My task is to extract multiple rows. Okay. So basically I'm trying to perform slicing on rows. Correct. So please everybody stop working. The things are going to get a little confusing now. Please focus, guys. Okay, slicing on rows. Okay, so this is actually possible for you to perform it in 3 methods. Okay, one is the normal method which we have studied until now. Then there is something called as lock method. Then there is something called as an iLock method. Okay, iLock method. These are the 3 methods which you can actually use to perform indexing and slicing on our data frames. Okay, now let us try to understand when to use what. Okay, so this data is very huge. One second, I'll just extract top 10 rows inside my data. I'll store this into a new data frame. New underscore data frame is equal to this one, and then I'll even replace the index values also. New data frame dot index. I'm just replacing the index values so that now we can work on one thing. E underscore dot append a row underscore whatever value it is, that is the value of the I. Okay, then again after this I'll just replace the index values dot index is equals to that empty list what I created. Okay, what I did is I just created a new data frame with top 10 rows, and then the default index values are there, no? 0, 1, 2, 3 like this. I changed it to a custom index values, row underscore 0, row underscore 1 like that. Okay, so for this particular set of rows over there, data, right? I'm sharing this code. Just copy and paste it and let me know if you guys are able to see new data frame like this. It is easy for me to explain it in smaller data frame. That's why I just cut shorted the data. Let me know if you guys are able to see a data like this quickly, then I'll proceed. Copy and paste. That's it, guys. That's it. Shall I proceed, everyone? Okay. Now everybody please stop working because this is going to be little confusing. That's why please stop working and then we'll come back. Okay. Now in normal slicing. Okay. Like even in at the time also which we saw. See, indexing and slicing can be performed in 2 methods. That is zero indexing and your custom indexing. Correct. So your custom indexing also it is possible. Custom indexing is also possible. Correct. So this is what we saw in case of series. Okay. So custom indexing is also possible. Okay. Now zero indexing and custom indexing. But one thing which we saw is if we are using zero indexing like this. Okay. So if you are using zero indexing like this, the rule which we saw is stat is inclusive. Stat is what? Stat is inclusive, and the value of your stop becomes what?
Exclusive.
Stop is exclusive, right? But on the other hand side, when we are dealing with custom indexing, there was a change which we saw in case of series, right? What is the change?
Both start and stop are inclusive.
Both start and stop both will become inclusive, right? So start as well as your stop, both will become inclusive. That is what we saw at that time. Okay. Now let us come back, right? So now see, normal slicing, the method which we have studied until now, that is also possible. Okay, so you can actually do it in both of these methods. Okay, so without the functions now, you can actually do it without the functions as well. Okay, easily it is possible, but there is a drawback. The drawback is basically what? Okay, so for an example, let us try to understand this, right? So let's say this is the data. On the left hand side, focus on this. We have custom index values. Okay, now can I give, let's say over here, start from, let's say for an example, start from 1 and go until 4. Okay, or let's say go until 4, something like 4 or 5, what it is, right? Now the question is, now count the index values. This is 0th index value, this is 1, this is 2, this is 3, this is 4, 5, similarly all of this, right? See, this is what I'm using, 0 indexing, or am I using custom indexing over here?
Zero index.
I'm using 0 indexing, right? So in case of 0 indexing, see, right now I am telling that, hey, start from here and stop until here. Now the question is, will you have this row in your output? Yes or no?
No.
No, it will stop one value before that, correct? So your output will be until the row underscore 3 over there. So if I execute this, only until row underscore 3 will be present in your output, correct? So see, 0 indexing is possible, as well as if I want, okay, now see, you help me to extract. I want to extract these 3 rows, but by using custom indexing, what do you think I need to provide? Row underscore 3, 4, 5, 1. So these 3 rows. That is row underscore 3 until
row underscore 5.
Row underscore 5. Now one question for all of you guys. Will you have this row in your output, yes or no?
Yes.
The answer is yes, it is going to come. Because in Pandas, what will happen is, of Pandas, what will happen is, if you are using 0 indexing, start is inclusive, stop is exclusive, how we have in core Python. But if you are using custom indexing, both start and stop will become inclusive over here. That is what you'll. Okay. Now, Vacha, then both are possible, right? So what is the drawback of normal slicing, right? So why do we have the other two functions? Is there any particular reason for that? The answer is yes. There is a reason for that. The reason is, yes, using normal slicing, you can actually perform indexing and slicing on rows easily. But along with rows, can I perform indexing and slicing on columns also? The answer is no, it will not allow you. There is a drawback. That is where it is going to fail. That is why what we have. Okay, so in normal indexing and slicing, over here, indexing and slicing on rows is possible, not on columns. This will not be allowed. So hence we have the other two functions. Even if I try, it will fail. Let me show you, right? So let's say over here, this rows, but I don't want all the rows. I want some set of columns. For an example, let's say I want, let's say,
Sir, we can have the column names initially and then we can have a slicing, right?
Yes, that we can do it. See, this also, it is not telling that you cannot achieve it. See, like later on also, like this also we can do it, correct? So let's say over here again, pass a list of columns like this. You can go ahead and you can do it. This one, whatever it is, right? So this also you can do it, but in a single shot you will not be able to do it. So in a single shot, it is not at all possible. This is possible, but directly you cannot go ahead and perform it. Start from, let's say start station name over here, and then over here go until bike ID. This will not be allowed in case of our normal function. Without any function, this is not at all allowed. Okay, so then what is the solution? In a single shot, I need to perform indexing on rows and columns. How can I achieve that part? So that can be achieved by your something called as lock method. Okay, now lock method has advantages. Yes, slicing on rows and columns is possible. Yes, this point is very clear. But the thing is, what do you think I need to use? We have two types of indexing, zero and in custom indexing, right? But the thing is, in case of lock, okay, so in case of lock, only custom indexing is supported. You cannot do zero indexing at all. In case of lock, only custom indexing is supported. In case of iLock, zero indexing is supported. That is the only difference, guys. Okay. Now let us see, right? So in case of lock, okay, so only custom indexing is supported. Okay. Now let us try to look at this output. Okay. For an example, let's say we have this data frame. We have this particular data frame. Okay. Now without using function also we did it, right? But again, let's say using the function as well, dot lock, you can actually perform what? Indexing and slicing. But can I pass values like this? The answer is no, it will not allow you to do it. You cannot pass zero indexing at all. You cannot pass zero indexing, it will directly throw an error. Then what do I need to provide? You have to compulsorily provide the custom index values. For an example, let's say over here, start from, let's say 2 and go until, let's say, row underscore 5. Okay, so this is how you can perform indexing and slicing on rows using lock. But this was possible without the function as well, correct? What is an advantage over here? The advantage is simple. So the advantage is not just rows. You can also perform slicing on columns as well. For an example, let's say over here. Okay, fun question. What do you think? I need to provide the index value of the column names. Let's say start from 1 and go until 4 like this, or the names of the columns.
Names of the columns.
Names of the columns, right? So start from start something like this and go until like this, right? So now you will be able to perform indexing and slicing on rows and columns in a single shot. Hey, I'm just giving one example. You can also take steps also, guys. Okay, so really sorry I did not tell this, but again, you can. But this is common, right? So not just indexing and slicing, not start and stop. You can also pass your step values also. Like this, you can perform. The point over here is rows and columns separated by comma. You can easily do it. That is an advantage which lock provides you. Clear?
Mm-hmm.
Okay, now wait.
How to extract random column name?
Random column names. Let's say anywhere in between like that and all, no?
Then particular one or two.
Yeah, let's say over here, which all columns you want to select? I remember. You tell me.
Start time and bike ID.
Start time and bike ID.
No, it is end stationary.
Let's say, okay, so start time, end station name and bike ID, correct? Okay, in that case, remember, we did the same concept in our NumPy. Okay, for custom, okay, wait, let me take this to that place where we have actually done it. For custom columns or custom rows, remember in our NumPy also we did something. We provided the data into a form of a, if there is no pattern, notice we provided as a form of a list, correct? So see, rows has a pattern, columns do not have a pattern, because see, here I wanted start name, start time, then this one and this one. There's no pattern. I cannot take any step at all, right? So in that case, simple. Go ahead and provide the names of the columns into a form of what over here is basically you can provide the name of the columns into a form of a list now. Simple like this. So like this, and n number of columns you want, you can include it. Is this point clear for everyone?
Okay.
This is also possible. If there is no pattern, guys, right? See, if you have a step, simple, take step. If you do not have a step, don't get worried at all. You can even pass it as a form of a list as well. Okay, now I'll change my question. Now coming, if you, okay, wait, before I go to that question now, one question, guys. Any questions in lock? What is the difference between lock and normal method? Without using this also we can do it, right? What is the difference? What difference do you actually see?
Normal method, I think. Both row and like index and column, we are giving it in a single shot.
Yes, right. So rows and columns, indexing and slicing, we can directly perform it in a single go with, right? That is possible in case of lock and lock method, right? Okay, now I'll change the question.
Sir, one question, sir. Okay.
1 second, Harshit, I'll come back. Huh?
Okay, sir.
What
Okay, fine.
if the data does not contain custom index values like this? See, here I change the data. Okay, so it is row underscore, it is there. You have custom index values now. What if the data contains index values like this? 0, 1, 2, 3. This is nothing but our zero indexing, right? Now the question is, hey, now is this possible over here? I'll take from, let's say, start station name and 2 until, let's say, bike ID. Now will it again throw an error? Will it again throw an error? Because here again we are going back and providing what? Zero indexing value, right? So the answer is it will not throw an error. What will it do? It will treat the index values as form of what? It will treat the index values as form of an custom index values. Now, if that is the point, you tell me, will you have this row in your output? Yes or no?
Yes, because it is treating it as custom.
Exactly. Now it is treating it as custom index value. Okay. Now wait, I'll change the question. Wait, I'll just remove this one over here. Okay. Okay. Now without using lock function, I'll remove the lock function. Now without the function, will you have this row in your output? Yes or no?
No,
No.
because it is treating
No.
it as zero index.
As
Zero
zero
indexing,
index.
no.
Now everybody is getting the difference. How it is working? Okay.
Can
Now.
you explain one? I didn't get it. Sorry.
Okay. Now, okay. Let me explain it again. Right. So I'll do it over here. Okay. So let me remove this one now. Just imagine this part. Okay, so see, in simple, what did we see right now? We saw that lock only supports custom indexing. Lock does not support zero index, right? So that is what we saw. See, if I try to pass in this new data frame 1, 2, 4, it will directly throw an error. But the same thing, if I'm providing the custom index values now, it is working fine, right? So here the data frame contained like this. The data frame had row underscore something like this. But what if the data frame does not have that? What if the data frame already contains custom index value? Sorry, zero index value like this. Now will lock function again throw an error if I pass, let's say, start from 2 to 4? The answer is no, it will not throw an error. Then what will it do? If you're using lock function, it will see if your data contains zero index values like this instead of custom. It will treat them, even though it is not custom, it will treat them as custom index values. If it is custom index value, see, if I'm giving 2 to 4, will you have row number 4 in case of custom index values?
Yes.
The answer is yes, right?
Yes,
So that
yes.
is why 2 to 4, see, row number 4 is present. But same thing if I do not use lock, same 2 to 4 if I'm providing. Now will you have row 4 over here?
No.
No. Why? Because it is now treating it as form of what? Zero index values over here. Clear, everyone?
But on top, it was giving error, right? You showed one error in that.
So if your data does not contain zero index values like this, if your data contains like this type of index values, you cannot by default provide it. Where is 1, 2 to 4 if I give? There's no 2 over there, right? So it will throw an error because I was performing it on new data frame, that is which contains custom index values.
Okay.
That's why it threw an error. Okay. Now, last.
I have one question here. You said lock works on custom indexing, but you did df.lock and then the number means you provide index in the form of number. It still worked.
Why? Because the data, does it contain something other than this index values? See, okay, here new data frame, I can provide 0, row underscore 1, row underscore 10 like that. But this data itself contains zero index value, right? So 0, 1, 2, 3 itself. Now, if I am using lock, see here in new df, if I pass, hey, start from 2 and go until 5, it is not present. Here it is not present. Even if it is searching, it is not present. But here in df, it is present, correct? So start from 2 and go until 4, it is present, right? So here it will fetch it out, but it will treat it as a form of what? As a custom index value.
The only output will change, but it works with lock or without lock.
Yes, it works, but depending, because this is treated as a custom index value, this is treated as a form of a zero indexing over there.
But in DF also, after changing to custom indexing, when you are doing zero, it was working, right? Only it was exclusive. That's the only difference.
That is the only difference. See, so here start and stop. If lock treats them as custom indexing 2 to 4, even 4 is also present in my output. But over here, same 2 to 4, 4 is not present. Why? Because it is treating it as a form of a zero index values over there.
Okay, so meaning we have this whatever row we have present in a data frame, if we use lock, it follows custom indexing.
Exactly.
Not to confuse with the DF simple 2 to 4 that follows zero indexing.
Exactly. Okay, wait, one more point, guys. Just a minute, I'll come back to the questions here. Okay, now just one integration from here. Okay, so but there is a problem again in normal indexing and slicing, right? So this contains problem. What is the problem? Yeah, rows you are performing it, but columns, can I perform indexing and slicing like this in case of this one? Yes or no? Normal.
No,
you
The
cannot.
answer is no, you cannot. Acha, what about in this function? Can I perform indexing and slicing on columns now?
Yeah, we can.
Yes, you can do it, right? But okay, what if now the data is 1 trillion records, right? So at that time, literally, it becomes very difficult, right? So we have one more option. Okay, we have one more option, the last option. So then, similar to lock, there is an opposite function as well that contains something called as iLock function. Okay, see, the name itself will give you a hint what lock is it actually. So that is iLock function. I means what? There's a meaning for I. Index lock. Okay, so here indexing and slicing on rows and columns is possible, first advantage. But do you think it will support custom indexing? No, it will only support zero indexing. Acha, if it is zero indexing, then what will happen? Start and stop, both will be inclusive or what?
No.
Will it
Both will
change?
be exclusive.
Both will be exclusive. Now, one is start is inclusive, the stop is exclusive over here. Okay, now let us understand as a data level. Okay, now I'll take that new data frame as an example. Okay, I have this type of data. First question, dot iLock. Can I give, let's say, start from row underscore 2 and row underscore 5. Will this work?
I think
iLock.
Yes. No. It's not zero index.
This will throw an error. Why? Because iLock, you are supposed to pass only the zero index values. You cannot pass custom index values. Okay. Now, yes. Okay. In that case, if this is your data, and here, yes, I can go ahead and do iLock, start from 2 and go until, let's say, for example, 5. Okay. This is possible, right? So start from 2 and go until 5. One question, will you have this row in your output?
No.
No. Why? Because stop is exclusive. You will have only until 4. Okay, so you'll have only until 4. Okay, so run this code out. Notice only until 4. Okay, but this was possible without the function as well. Correct? Without iLock also, I can actually achieve this part. It is directly possible. Right? So same output I will have it. But the advantage is basically what? The advantage is not just on rows. You can also perform indexing and slicing on columns as well. Okay. Now one question for all of you. What do you think? Tell me logically. Names of the columns I need to provide or the index value of columns I need to provide over here?
Index must be.
Index, sir.
Exactly. Right. So the index value. Okay. Now you tell me. I want this output. What is the start value and what is the stop value? 1 to what?
1 to
So 1, 2, 4, 5, 6,
8,
7,
8.
and 8. Hey, I don't want this now in my output. I only want until
That
by
is
8.
exclusive.
Exactly. So you'll provide until 8. Understood? How it changed? See, when I used lock, I used pass the column names and both are inclusive. But if same thing if I'm using iLock, rows and columns, right? So stop will become exclusive over here. Got the difference, everyone?
Sir, in NumPy, can we use both zero and custom indexing in NumPy? Like how we are using here in Pandas?
NumPy only zero indexing is allowed. There's no other option at all. There's no column names at all we can assign, right? That's why. Okay.
But sir, since we will be having millions of entries, right? This will be hectic to find the index for columns, right? This is easy for us.
Yeah, because yeah, so what Krishna is actually telling is a very critical point, guys. Okay, so imagine one case. See, this data frame contains how many rows? Okay, so wait, I'll take dot shape. No, shape is an attribute, right? So to get the fetch of rows. Okay, this one I'll just take the 0 value. These are the total number of rows present inside my data. Correct. Now imagine the same thing. Let's say over here, my task. Imagine there are 1 trillion rows, right? So now we all understand that. Remember the big data also a concept which I was trying to explain it to you guys. One single machine, if I'm trying to process 1 trillion rows, it is not possible. So what we're trying to do is, okay, I'll take one example. There was one code which we did, right? So this file contained 1 GB. Okay. So what we did is we splitted this particular data, 1 GB data, into multiple files. Okay, so let's say this one is 10 GB, like this, right? Multiple files. So how can I achieve this one, right? So see, this can be easily achieved. So in this case, if I want to do what, right? So let's say this, I want to split it into 2 equal partitions. So this flow divided by 2. Okay, you'll have this one. So what I can do is df.lock dot ilock. Okay, so start from the beginning and go until what, this part. Okay, this one. So this will fetch you first half rows. Then second set of file, right? So second set of scenario. Start from this and go until the end. This will get you the second set of rows. You have to think logically to set this one. Okay, everybody clear now? Everyone, any questions?
So, sir, this in normal Pandas terminology, what we call it as the each value. For example, any station name value. For example, rows and columns were telling us rows and columns. For example, City Hall, in normal terminology, what we can say for City Hall are Lincoln Park, these things. Items are.
So what is each value called over here?
Yeah, in normal Pandas terminology.
You call it as value itself.
Only.
Value itself, yes. There's no other name for this. Only the thing is series and data frames. That is what we use, but rest and all value same itself over there.
Because why I'm saying is, while you are explaining about lock and iLock, the normal indexing value starts from 0 when we are changing using some code to custom indexing values. People are getting confused with that zeros and the assigned this row underscore values.
This one?
Yeah.
Okay. So now why I did this part, right? So for me to explain how does your pandas work when it is custom index value?
Yeah, I got it. But most of people, what I saw is getting confused with normal indexing, Python indexing, and the assigned indexing one.
Okay. Then so then we'll do one thing, guys. Just to avoid confusion, I'll list all of these 3 things over here so that it is easy for you guys later on to remember these points. Okay, so help me to list them out. Key points which we need to remember for all of this. Normal slicing. Okay, then again we saw something called as lock method. Okay, then again we saw something called as iLock. Okay, what did you guys understand with this part? Normal slicing, guys. This is for everyone.
Start is inclusive and stop is
No.
exclusive. Columns we cannot provide along with the row slicing.
Slicing on rows is possible, correct? So slicing on rows is possible. Okay, but this point, is it applicable for all of the below points?
Yeah.
For lock also it is possible?
Correct.
For iLock also it is possible?
Yes.
Achha. But coming to the second point, slicing on columns, is it possible?
Not possible.
No.
Slicing on columns is not possible. Okay. But what about in the below two side? Is this possible?
Yes.
Columns
Possible.
is actually possible. Columns, it is actually possible over here, as well as in this case also slicing on columns, it is actually possible. Okay. Now in normal slicing, we can do this indexing and slicing in two methods again, right? So that is our zero indexing, and you can also do the same thing by your custom indexing, right? So custom indexing also it is possible. Okay, but if we are talking about zero, what are the points? What changes? Start is inclusive, and the value of your stop will become exclusive over here. But on the other hand side, if you are using custom indexing, sorry, this is custom
Both are
indexing,
inclusive.
start and stop, both will become inclusive. Okay, but on lock, will this support again both of this? Will lock support both of this?
No, only custom it supports.
Custom indexing.
No, it will not support. It will only support the zero indexing. It will not support. It will only support the custom indexing. But on the other hand side, will this support both of this, lock and iLock? Sorry, iLock.
Only zero indexing.
Only zero indexing is allowed. Custom
Yeah.
indexing is not allowed. Only these are the points which you need to remember, guys. That's it. Okay. Now,
Sir, on
okay.
normal slicing, you've mentioned slicing on column is not possible. We had performed, right, slicing on column.
Slicing
Getting
on
confused, I
columns.
think.
Let's say over here, this is my data frame.
But for stop, it is inclusive, right? For iLog, stop is inclusive. You mentioned exclusive in zero indexing, right?
It is exclusive. Huh. Correct. The start is inclusive, stop is exclusive. Start is inclusive, stop is also inclusive.
But iLog, it is inclusive, right? No?
Start and stop? No. It works as form of zero indexing. Zero indexing means start is inclusive, stop is inclusive directly. Okay. Now, okay, let me quickly recap this one, guys. Okay, so see, in this case, this is my data frame. I'll not use any function. I have a task where I need to extract water from here to here. Row 1 to 3. Can I extract it? Yes or no? 1, 2, 3.
Yeah.
That's possible.
1 to 4.
That is 1 to 3. If I pass, will you have this data in your output? No. That's why we'll be providing one value ahead of this. So 1 to 4. Okay. Now this is my data frame, right? So now, okay. So now second thing. But I don't want all the columns. I want only alternate columns. From here, this column, this column, this column, like this, alternate columns. Can I perform slicing over here like this? Let's say start from one, go until this one, and take the step as 2.
Yes.
No.
Yes.
The answer is
No, we cannot.
no. This is without using any function. Slicing on columns is not at all allowed. Okay, what if can I pass the names of the columns then over here? Let's say start from, let's say, start time and go until
outside we can provide it.
That is in a different syntax, but again directly here in this bracket itself.
Okay, meaning the slicing specifically cannot do column here. We can do outside
slicing on columns is not at all allowed.
We can give another index and do on the columns, no? That is possible.
That is pinpointing it. You are pinpointing one column at a time. Let's say there are 100 columns. Pinpointing 100 columns, it is very difficult, right? So slicing helps you out over here. Okay. Now slicing is not possible on columns if you are doing directly like this. Okay, then now coming to the lock. Dot lock. Okay, my data is like this. The data is like this now. Okay. Now in my data frame, dot lock, if I give, let's say, start from 1, go until 4. What changes over here? Wait, this start from 1 and go until 4. Here I have this in my output. If I execute the below code, what will be the output? Same output or different output? Dot lock.
Exclusive.
The row 4 will be
different. Row 4 will also come.
Will also be present because it treats them as what type of index values? It treats them as custom index values, right? So that is why we have this in my output. Okay. Now here, can I do slicing on columns then? The answer is
yes.
Do you think I need to pass the index value of columns like this?
Yeah.
It won't work here.
No, custom index
It won't work here.
Will work?
No, it will not work. Huh? So why? Because this supports only custom indexing. So hence names of the columns is what you will be providing start name to bike ID or something like that, right? So you'll be providing the names of the columns like this. Okay, so this is what lock function. Okay, but the
Can we
same
add
thing.
step? Can we add step here?
Yes,
Start
yes,
back.
yes. Like this, right? So yes, you can have step in both these places, right? Okay, now the same thing. I can also do the same thing by iLock, but start from 1 and go until 4. Will row 4 be present in my output? Yes or no?
No.
No.
No. No.
The answer is no. Why here it is not there in the above and it
Zero
is there?
indexing.
This supports zero
Zero
index. Okay.
indexing.
Basic.
Now I need to perform slicing on columns. Is it possible? Yes.
Yes.
No.
Yes.
Pass the names of the columns.
No. Zero indexing.
No.
You need to provide the index value for that particular column. Start from 1 and go until 4. Okay. So this is start 0, 1, 2, 3, 4. Will you have this column in your output? Yes or no? Start
No.
station name.
No.
The answer is no, because stop is exclusive. Clear, everyone? 3 points.
Yes, sir. It's clear. Little confusing, but fine.
I told you it is going to get complicated. That's why.
But this
Okay.
quick summary really helped. Yeah.
Okay.
LOC,
Now,
for LOC, you said custom indexing start is inclusive and stop is inclusive, right? But when you write df.lock, we did not change anything. It was just a default indexing only, right? Then how come it become custom indexing?
wait. Here dot lock 1, 2, 4. Okay. So this is lock function I'm using. In zero indexing, wait. If I'm by chance if I'm using zero indexing, start is inclusive, stop is exclusive. Correct. Here, in case of lock, it treats them as a custom index value. So
Okay, it treats, but actually it is default indexing only, but it treats as a custom indexing, right?
yes, default index value, sir, but it is treating it as custom index value over there. Okay, can you paste it over here? Yes, Keshav, let me paste it. Okay, now coming to more complicated. Okay, at least here it was very simple. You can, if you just go through this again, right, you can still understand this part. Now coming to the more complicated part.
One question
Filter.
before we move forward.
Quickly.
I just trying this iLog. Okay, I just pasted 2 snippet there. In the chat box. Second one we understood. First one I mistakenly did, and it is giving me something else.
Correct.
What is this?
So wait until here. Okay. So this is your output. That is you're doing it in new data frame. Then again, this imagine now this is a new data frame. Okay, so here this is the data frame. Now again on this data you are performing start from 1 go until 8. So from here to 8, if it was present, it would have given, right? So
okay, so another script treating it as again a row slicing. Okay.
Exactly. Okay, now coming to the complex part, guys. Filtering the data is also possible on your Pandas. The syntax is a little complex than your SQL. Literally, SQL syntax are very, very simple. Okay, let us understand what exactly is. Please stop working, everyone. Try to focus on this part. Okay. Now I have a task. My task is to do what? My task is to filter the data. Means, let's say, here we have two columns. This column, we have two unique values, right? So subscriber and customer is there, correct? So subscriber, customers, and all it is present there. I don't want to work with customer type of data. I only want to work where the user type is equal to subscriber, right? Only this type of data I want to work. That is my task. I need to only extract this type of data in my output. How can I achieve this? Okay, if you are talking about SQL query, what will your query be? Select star from your table where
user type equals to
is equals to subscriber is what you'll be providing it in your SQL query over there, right? This type of filter condition, can I apply it in our Pandas data frame? The answer is yes, you can actually do it. But how? So there are multiple syntaxes, guys. Okay, so do not get confused. It's your wish. Depending on what is easy to you, you choose your syntax. Okay, let me show this step by step. Now, how can I achieve this? You can actually do this in your lock, iLock, or without this one also. Basically, indexing, if you remember, in NumPy also we saw, in indexing and slicing square bracket, it is not just this. You can also pass conditions also. You guys remember this? We can also pass conditions also, right? Same thing over here also you can provide, right? So df of this particular user type equals to what? Equals to subscriber. Okay, so I'm trying to do what? I'm just trying to pass a condition. Now go back to our NumPy. Will you have the data where user type is equals to subscriber, or what do you think we'll have? We will have, so remember, where the if I'm just passing the condition, where the condition is true, it will give you true. Where the condition is not matching, it will give you false, correct? So if I run this code out, same thing you will have over here as well. Where the condition is matching, no, it will give you true. Where the condition is not matching, it will give you false. So here you can answer two questions. The total number of values like subscriber you can answer if you get the sum of this one, right? Those type of answers you can do it. But what you can do is, but my task was to extract the data which is matching my condition, right? So that condition you can pass it inside your indexing and slicing square brackets as well. Now run the code out. What is the output which I'm able to see? I'm able to see only the data where the user type is what? User type is subscriber. That is how I'm able to filter the data. Okay, what if I want to put in multiple conditions? So extract the data where the user type is equal to subscriber and the trip duration should be greater than 1000. Okay, so that is my task. How can I pass multiple conditions? Okay, so if you remember, go back in NumPy. For multiple conditions, yes, you can pass it. But if you remember, something changed. Do we use A and
Or
D in case of and? No, right? So and or the symbols which we use. Why are we using the symbols instead of these words?
C
Because Python support.
language.
C language, yeah.
Right. So you can pass not just one condition, literally like this, where user type is equals to subscriber. You need to, okay, one question. Second condition I'll provide, but what will be between A and D or ampersand?
And
A and D? Ampersand, right? Okay, here you can now provide second condition, whatever condition. See, I'm just now as an example, I'm giving what? So let me just take trip duration is equals to where df of trip duration is what is greater than or equals to 1000. Like this, I can go ahead and I can filter the data using this syntaxes. Okay, now everybody open your Jupyter notebooks. I want you guys to answer this. This is a syntax for reference. I'm keeping it. Okay, so help me to extract.
Yeah, one more thing, like can we use in and all here?
No, the answer is no. You cannot use in parameter. You cannot use in parameter. You can only use and or. For in operator, na, the syntax changes little bit. I'll show you how you can do it. Okay. Okay, help me to extract the data where. Give me a minute. Okay, I'll keep this first task simple. Second task I'll complicate it. Okay. Help me to extract the data where. Okay, trip duration. Okay, check this, guys. Okay, is between 1000 to 1500. Keep both inclusive. Help me to extract the data where the trip duration is between 1000 to 1500. Keep both of these values inclusive. Give me the code that will help me to do it. As a reference syntax, you have the syntax over here. Everyone try it out, even though it looks simple now. Try it out. Why? Because these brackets and all which I have given, right? It is not just like that. You need to compulsorily give them. Try it out, guys. Only then you will understand these points. How many records are present like this?
1739 records.
Yeah, 1739.
Okay. So let me copy and paste any one of you guys' code. Run this code out 1739. Yes, awesome. We are able to extract the data within this particular range. Okay. Wait, one more task. Now I'm going to complicate it a little bit. Help me to extract the data. So extract the data where okay, so where start station name is same as your end station name. So this data is a type of we have Denso and all right in our India. So similar to that one, right? So I want to understand if there are any records where the start station name and the end station name both are same. So there is a city hall means over here also it should be city hall like that. That type of records I'm just out of curiosity I need to understand if it is there or not there. Give me the code that will fetch me this particular records. How many rows, Krishna?
1544.
Oh, okay.
Yes, 1544.
Okay, let me copy any one of you guys' code. Equals to this one, right? So it is pretty simple. Now I'll just copy and paste any one of you guys' code, run this code out 1544. Yes, we are able to see that type of data over here, right? So start station name and then the end station name, both are same over here. This type of data is also present. Okay. Now come into the complicated now. Okay. Now this is my data frame. Okay, here I'll try to introduce another topic. That's why I want you guys to answer this one, guys. Okay. Help me to extract the data. Three conditions I have. I want to extract the data where the trip duration is less than 1000. Okay, so I want to extract the data where the trip duration is less than 1000, and the start station name. Start station name can either be either it is equals to, let's say, Grand Street, or it can be a city hall. So if you're talking about an SQL query, it is going to be something like this. Let's start from the table where the trip duration is greater than less than 1000, and this or this one, right? So start station name is equal to either Grand Street or city hall. Yes, I know in SQL we have a simple parameter in operator, but here you do not have it. But help me to fetch this particular data. We'll stop this after the class after this question, guys. Then we'll continue the next things in tomorrow's class. Done? How you pass it, I want to see how you think out of the box. Okay, let's see how you guys have done it. One bracket out there. Perfect. Anita, you are correct. Vinay, correct. Mohan, correct. Arunima, awesome. Murli, awesome. Harshita, awesome. Awesome, guys, awesome. Okay, what is the change which you guys did over here? Basically, passed each and every condition in a square bracket, right? So yeah, that is one thing. Or is this one, and then this whole is one condition, right? So this whole thing in a single bracket you have passed it. So awesome, right? So run this code out. 764 rows. Am I correct for this one?
Yes.
Right. Awesome. Okay. But anyone who has worked in SQL query, how do we do it in SQL query? Let's do that over here. So select star from that particular table where your start trip duration is less than 1000, and this
Startation name in.
Exactly, and this in your this value. Okay, so in this value and this value over here, correct? Okay, the advantage, which has an advantage, which has a drawback. There's one advantage in one place, there's one drawback in another place. What do you think? Okay, what if I want to add one more value, which is easy? This below syntax is easy, or SQL is simple, right? Okay, don't you think if we had an option like this will help us out in case of pandas?
Yeah,
What
absolutely.
in operator if
Yes,
it
sir,
was
very
given,
much.
right? Because okay, see, two values and all, or you have used awesome, okay, but let's say 10 values like this, literally you are copying pasting this one and again this again, or then again keep on doing this one, right? So that will become very hectic, right? So if we had an in operator, it will be actually helpful. Okay, so but for this now, let's do this in tomorrow's class. Okay, so let's learn this in tomorrow's class. Done?
Sir, is there any way we can get SQL code into this?
In pandas, no. In PySpark,
No.
yes.
Okay, sir.
Okay, so we'll learn this in tomorrow's class. Then there is an in operator. We'll do it. There are two syntaxes for that. We'll learn this in tomorrow's class because it is. I think it is becoming too much in today's class. We'll do it in tomorrow's class. Okay.
Can you share this file on the chat?
Sir, I have one question. When I'm using the filter as grand, I'm getting 764 rows, but when I include that ST, it gives 1106 rows, more rows.
ST.
Grand ST, right?
Oh, grand ST it is actually. Sorry, my bad. Hey, our task was to extract with grand ST itself. So the total number of count is what? 1106. Yeah, 1106 number of rows. You are correct.
So
You are
is it
correct,
matching partially for grand, or only the grand is also an entry there?
Grand is an entry over there. It is not like operator is not at all present in case of this one right now.
Also, I did a very critical, one very basic mistake. I use ampersand in first, and second I use OR. So that didn't work for me.
No, that will not work. Why? Because NumPy and Pandas are not at all built in Python. They are built in C. C and an R itself is not there, right? So there you have the symbols. That is what you have to use it.
Yeah.
Okay. Okay, I'll stop the class. Let us continue this in tomorrow's class. Have a great day ahead, guys. See you guys tomorrow. Done?